So growing up a Bears fan all my life, I got really excited in the early 2019 when the Bears went to the NFL playoffs for the first time in about 8 years. And obviously, like many Bears fans, I watched it only to see them get knocked out in the wild card round by a missed field goal. Now, had it gone wide, that would have been one thing, but that year the Bears were plagued by a whole bunch of kicks that hit the goalpost. And everyone kept asking the same question. What are the chances of the kicker hitting the field goal post? And so I've decided, you know what, I'm going to try and answer this question as best I can. And this is not going to be a single video. It's way too complicated for that. So I'm going to start simple with this video, and then we're going to start layering in more and more things that make the answer a little more nuanced. So the kick in question from the NFC wildcard game was at the 43-yard line. Now, it was actually on the right hash mark, or the left hash mark, I can't remember, but we're not going to do that for this video. That'll be a future video. We're going to put it at the center of the field for right now. Now, the field goal posts are way over here, right above the end zone. Now, according to the NFL, this is 18 feet 6 inches wide. Now, let's do this entire calculation in inches just to make it easy on ourselves. So this is 222 inches in width. Now, the interesting thing, and if someone can point out a source that can tell me otherwise, I'll be glad to hear it, but no one ever says whether this width is the inside or the outside. And so I'm just going to assume that it's the inside. Again, please comment in the comment section to let me know, because different people will say different things. Now, the width of the actual pipe is 4 inches. And I found several sites that corroborate that. Okay. Now, the end zone is 10 yards wide. So that is 360 inches. Now, from the end zone out to the 43-yard line, so that's 43 yards. So we have to take 43 yards times 3 because there's 3 feet in a yard, and then times 12. So 43 times 12 times 3 is 1,548. 1,548 inches. Now, why am I calculating all this? Well, what I'm doing is, what I want to figure out is, what is the angle? What is the angle window between the ball and the two edges of the goalpost? Now, this angle has to be really, really narrow, but it has to be something. And so what I'm going to have to do is I'm going to have to use a little bit of high school trigonometry in order to answer this question. All right, so what I have to do is I have to measure the angle from the ball to the inside of the goalpost, and then measure the angle from the ball to the outside of the goalpost. Okay, so what I'm going to do is I'm going to draw with this color. So we'll use blue, and so draw right down the middle. So this line is the length of 360 plus 1,548. We'll add those together. And we get 1,908 inches. Now what I'm going to do is I'm going to measure this side, and I'm going to measure out to the inside of the goalpost. And so that's going to be 222 divided by 2, which is 111 inches. So what this tells me is, this tells me the inside angle from the center line out to the inside of the pipe. And so what this is this is a right triangle. The angle in question is right here. 111 is opposite, and 1908 is adjacent. So if you remember SOHCAHTOA from high school trigonometry, we'll call this angle A. Opposite and adjacent, we're going to use tangent. So over here, so tangent of A equals 111 divided by 1908. Now to figure out the angle, we're going to take the inverse of that on our calculator. So tan inverse of 111 divided by 1908. And we get 3.329 degrees. So that's the angle from the center line to the inside of the pipe. So now on the other side, now we have to calculate to the outside of the pipe. Now the only difference, this side will be the same, but now we have to tack on an extra 4 inches. So this length out here is 115. And I'll call this angle B. Because we're doing it down the center line, it's going to be symmetrical either way. So we take tangent of B, that angle is equal to 115 divided by 1908. So to figure out that angle, we're going to take the tangent inverse of 115 divided by 1908. And so we get 3.449 degrees. So what is the difference between them? Because that's going to give us how wide of an angle it is to actually hit the pipe. So 3.449 minus 3.329, 0.12. And we, not divide it by 2, multiply by 2 because there's one pipe over here and one pipe over here, so we have to double that. So we have 0.24 degrees of angle. Now that actually doesn't answer the question, what's the probability? So what we have to say is, well, what is all the possibilities that we could have? What are all the possible angles that this ball could be pointed at? And there's no actual answer. I have a source that will help inform us a little bit. I'll put that in a later video. But for right now, let's just say that the ball could go anywhere this way and with a 90 degrees of width. Now, some people in Chicago are probably being cynical right now and saying that, well, that ball could go anywhere, not just in this direction. But for right now, 90 degrees. So to answer that, we calculated that there is 0.24 degrees that will hit the pipe, divided by a total of 90 degrees. So 0.24 divided by 90, that gives us 0.0026. 6 repeating. So that's actually, if we write that as a percent, that's 0.26 repeating percent. So there's a less than 1 in 100 chance. This is about a 1 in 500 chance of hitting. Now, this is a good start, and we're going to have some other videos. But one of the key flaws is that it assumes that it's equally likely for the ball to go wild this way as opposed to right down the center. And we're going to compensate for that in a future video, along with another future video where I'm going to help us narrow this down a little bit. But thanks for watching. If you see any mistakes or have any sources for me to look at, please let me know in the comments. And I look forward to more of these videos to answer this question.